for the function f of x is equal to ax plus b when x lies between 0 and 1 to be a valid probability density function, which one of the following statements is correct? So this function is defined between for values of x between 0 and 1, and we know that for a function to be a valid probability density function, its integral value between minus infinity and infinity must be 1, or rather the area of that particular function must be 1. So in this case, I can directly write that integral 0 to 1 of f of x is ax plus b, right? Ax plus b dx must be 1, provided this thing is a valid PDF. So if I integrate this particular thing, I can write ax square by 2, right? Ax square by 2 plus bx with limits 0 to 1 must be 1 for this thing to be a valid PDF. So if I apply the limits, if I substitute 1 for x, I'll be getting a by 2 plus b, right? A by 2 plus b. Now if I substitute 0, I'll be getting 0, so I need not subtract it, or rather if I subtract 0 from this particular thing, I'll be getting just a by 2 plus b. So this must be 1, which means that a by 2 plus b must be 1. So when you see the options, you can say that, suppose if this were the right answer, a by 2 is 1 by 2 plus 4, it's not 1. Whereas in this particular case, if I substitute a is equal to 0 and b is equal to 1, I can see that a by 2 is 0 plus b, which is 1, is 1. So this must be the answer, because it is only in this particular case that a by 2 plus b is 1, which means that this is a valid PDF. So the answer must be option 3. A two-faced fair coin has its face designated as head and tail, represented by H and T. This coin is tossed 3 times in succession to record the following outcomes: head, head, head. So 3 times consecutively you have got heads. Now if this coin is tossed one more time, the probability up to 1 decimal place of obtaining head again, given that the previous realizations of H, H and H would be, which means that already the given condition is that the previous 3 tosses were all heads. Now you need to find the probability of getting a head again. So you know that these events are independent. When you toss a coin for the first time and again you do the toss for the second time, you know that this outcome is not dependent on this outcome. This outcome is not dependent on this nor on this. So you can say that the final toss, the probability of getting a head will be 1 by 2, and again the probability of getting a tail will be 1 by 2. You already know this. Now to get a better insight into this, we can consider solving this problem in 2 different other methods. One method is simply based on your logic. See, you have 1, 2 and 3 different tosses, which means that you will be having 2 raised to 3 different outcomes, which will be 8. So you will be having 8 different outcomes, of which H is one such outcome, and hence the probability of getting this thing will be 1 by 8. I already know this. Now since that this condition is given, I know that out of all these 8 different possibilities, I am restricting my outcome to just this thing. So if I go for the 4th toss, the possible outcomes will be H, 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 H or H, 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 T, because I don't have a different option. For the first 3 tosses, it is given that the first 3 tosses were all heads, which means that these 2 are the only options that I am left with, and these 2 are equally probable, which means that this particular sequence happens with a probability of 1 by 2 and this particular sequence happens with a probability of 1 by 2, which means that probability of getting head in the last toss will be 1 by 2, and the probability, of course, of getting a tail in the last toss will also be 1 by 2. So in that manner also I know that the question is to find the probability of getting head again is 1 by 2. Now, suppose if you want to solve this problem based on conditional probability, P of A given B, I know is P of A intersection B divided by P of B, right? So P of B is that condition, the probability of that thing which has already happened, and probability of A given B means this is given and you need to find this probability. So in this particular case, A is the event that the fourth toss you get a head, and B is the event that you have already got 3 heads. So I know that probability of, I am first going to write the denominator, probability of getting B means probability of getting 3 heads in the first 3 tosses. That will be 1 by 2 into 1 by 2 into 1 by 2, which is 1 by 8, right? 1 by 8. Now, the probability of A intersection B is simultaneous occurrence of event A and event B. Event B is first 3 tosses are heads. Event A is the fourth toss is head. So, if I want to make sure that these two things simultaneously happen, I know that this happens with a chance of 1 by 8 and this happens with a chance of 1 by 2, which means that the probability of getting head and a head will be 1 by 16, right? So this is 1 by 16, I'll write it here, this is 1 by 16 divided by 1 by 8, which is 1 by 2. So whatever be the method you deploy, the answer will be 1 by 2. So my final answer must be 0.5. The graph of a function f of x is shown in the figure. Now, for f of x to be a valid probability density function, the value of h must be. So this is a function. The value of this function between 1 and 2 is in this manner, from between 1 and 2, I mean 0 and 1 is in this manner, 1 and 2 is in this manner, and 2 and 3 is in this manner. Now, we know that for a function to be a valid PDF, for a function to be a valid probability density function, the area of that particular function must be 1. Or rather, if you integrate it from minus infinity to infinity, that integral value must be 1. Both these things are same. Now, in this particular case, I can say that this is the area. If I'm going to find first this area, right? Then I'm going to find this area, and then I'm going to find this area. I know that the area of a triangle, this is a triangle. The area of a triangle is half into base into height. So I can take this length as base and this length as height. So this area will be the area between 0 and 1 will be half, right? Half into this length is 1 into this height is h, plus this is half into 2 into, I mean 1 into height is 2h, right? This height is 2h. Now again it is half into 1 into this length is 1, right? This length is 1, 3 minus 2 is 1 into 3h. Now this must be 1. This total area must be 1. So this is half into, I need not consider ones. If I take half as the common factor, this is h plus 2h plus 3h, which is 6h. So half into 6h is 1, or h must be 1 by 3. So the value of h must be 1 by 3 for this particular function to be a valid PDF. Probability up to 1 decimal place of consecutively picking 3 red balls without replacement from a box containing 5 red balls and 1 white ball. So I have 5 red, 1 white. I have 5 red, 1 white. Now I need to find the probability of consecutively picking 3 red balls. Now there is a bit of ambiguity in this question. The question must be, if the question were, we will attempt the question 2 different ways. The first thing is, the first thing in which we interpret the question in such a manner that the first 3 tosses must be, the first 3 pickings must give us 3 red balls, right? The first must be a red, the second must be a red, and the third must be a red. In such a case, I know that for the first to be a red, out of 6, I have 5 which are reds. So 5 by 6 will be the probability of getting a red ball in the first picking. Now in the second picking, I'll be left with only 5 balls because I am picking it without replacement. I'm taking it out of which 4 will be red because already I've picked a red ball in the first chance. Now I'll be left with only 4, out of which 3 will be red, right? So 5 by 6 for the first red, 4 by 5 for the second red, 3 by 4 for the third red, which means that this has to happen and this has to happen and this has to happen, and they are independent, so I can multiply it. So this will be 3 by 6, which is 1 by 2, right? Now, since that in the question it is not given that you have to ensure that you will be getting 3 reds in the first 3 pickings. You have 6 balls, and suppose if you don't have a restriction on number of pickings, you can pick the entire balls from it one by one. So I can have 6 different pickings because I have 6 different balls. Now if I have a white here, if I pick white in the first chance, I can say that definitely I'll be having 5 reds in a row, which means that 3 consecutive red balls, the condition which I required, picking 3 consecutively picking 3 red balls, that would definitely happen. And if I had a white here, again, since that I have 4 different options for reds, all these will be red, which means that in this case also my requirement is satisfied. Now if I have a white here, again I have 3 here, so all these 3 will be reds because I have only one white. Now if I have a white here, these 3 will be red definitely because I have only one white in that box. Now if I go for a white here, again I can make sure that I'll be having 3 red balls. I can pick consecutively 3 red balls, which means that since that in this question, it is not given that you have to ensure that you will be getting 3 reds in the first 3 draws itself. It's not actually mentioned in the question, which means that even if a student writes that the probability of getting 3 consecutively picking 3 red balls is 1, logically that is correct, because if you pick all the 6 and if you have a white anywhere, if you pick white either in the first chance or in the second or in the third or the fourth or fifth or sixth, whatever it be, you can be sure that you will be getting 3 red balls consecutively. But anyway, I believe that the expected answer will be 1 by 2, and the question must be interpreted in such a manner that you need to find the probability of picking red balls in the first 3 chances itself.